Welcome to Physics with Miyoshi. Today we're going to talk about kinematics. And if you think about physics in terms of kinematics, which is motion without reference to force, we have dynamics, which puts forces in there, and those two fields together gives us mechanics. But today, all we're going to talk about is kinematics. So let's get rid of these guys for a moment. So, here's some definitions we're going to need to talk about. First of all, so it's a little bit of vocabulary. One dimension, that is just a number line that you're used to in math, going left and right on a number line. Normally we have positive and negative, negative on the left and positive on the right. Displacement means the total distance from your ending point to your beginning point, for instance. It doesn't matter what path you take to get there, your displacement is still the distance from here to here. So whether we take that path or some other path, the displacement is still the final displacement, or final position minus the initial position. Velocity is, we've talked about velocity already, but velocity is our how fast we're going, but velocity is also is a vector, so it has direction and magnitude. Speed is merely the magnitude of our velocity. Average speed is just like you would think if you know the distance you went and you divide that by the time that took you to get there, that would give you your average speed. And we'll talk about equations in a moment. Our average velocity is the same kind of thing, but it's how long it took you to get that displacement. So it is also a vector, and it points in the same direction as your displacement does. Instantaneous velocity, well, that's a little bit different, but if we have a graph here of our distance and time, and we have some kind of graph that does something like this, our instantaneous velocity is what happens if we change this time factor, if we make that change in time smaller and smaller and smaller to where we get a single time, then that whatever velocity it has there, that's our instantaneous velocity. And we'll talk about that more as we go along, and I'll give you a little equation over here in a minute. Acceleration is very similar to velocity. It's just the change in our speed or change in our velocity is our acceleration. And again, we have average and instantaneous. And then there's some symbols that you should be aware of. This is the Greek letter delta. It's usually used for, it means change in whatever comes after it. So we read that delta is our change in. So if we have delta t, that's change in time. If we have delta d, that's change in distance or displacement. D is normally used for displacement, V normally for velocity and speed, A for acceleration, and T for time. Over here we have a few equations that we will be using. Our delta D is displacement final minus distance displacement initial. Delta T, time final minus time initial. Our average speed is delta D over delta T, or change in distance over change in time. And our instantaneous velocity. Here's a little calculus for you. We have our instantaneous velocity is our limit as time delta T goes to 0 of delta D over delta T. Well, what does that mean? That means that if I have some graph, for instance, of my displacement, then what I can do is as I shrink this delta T smaller and smaller and smaller, I eventually get to a point where my delta T is very small, and eventually as that gets closer and closer to 0, that becomes my instantaneous velocity. So in reality I have a time of 0, my time change in time is 0, so I end up having a instantaneous velocity. And we'll talk about that more as we go along. Our Say analogously, we have our delta v is our change in velocity, is our final velocity minus our initial velocity, and our average acceleration is our change in velocity over change in time. And similarly, all we have to do is change this to v and change this to v. We could change our graph, but the acceleration, instantaneous acceleration, is the limit as delta t approaches 0 of our change in velocity over change in time. In one dimension, we often use velocity and speed interchangeably because we are only going on one dimension. But remember that velocity is a vector and speed is a scalar. Most of the time we'll be talking about acceleration in terms of the vector quantity, but there will be times when we just are worried about the magnitude, especially since we're only in one dimension. So, just a few things that we need to know, just a few vocabulary words that we need to start out to learn kinematics. And again, kinematics is motion without reference to force, and in this case, for right now, we're just using it in one dimension. So, we'll talk more about some applications of this as we go along next time on Physics with Miyoshi. Thanks for tuning in.